Before describing node voltage analysis, let me just make a couple comments. We note that in every circuit analysis, the foundation to analyze any circuits is the connection constraints or Kirchhoff voltage laws and current laws, device constraints such as IV relationships of the various electrical elements. However, when we do this technique of element constraints and connection constraints, this involves a lot of equations and a lot of unknowns. So node voltage analysis is used to help reduce the number of equations. However, we should not abandon the idea of connection constraints as well as device constraints. All that node voltage analysis does for us, as well as mesh analysis, is to help reduce the number of equations. Now let's go through some notation. Here we have a circuit with some devices, and we have basically 4 nodes, and what I labeled here is node voltage at A, node voltage at B, and node voltage C. In here I label a ground reference point, and we always note that the ground reference point is always like 0 volts. And how do you choose that ground reference points? Well, it depends on you, but basically you try to see where most of the devices are connected, and if a node such as this has a lot of electrical devices connected to it, we usually label it as the reference node. And again, the reference node is usually 0 volts. So here we have node voltage A and voltage B, and let's say this is device 1, 2, 3, 4, and 5. Now we want to find the voltage across, let's say, element 2. Well, the voltage across element 2, we'll say V2